So now we want to find the derivative of f and evaluate it at pi over 2. So this one is interesting. Whenever you have a cosine or any trig function to a power, it's best, when you're doing derivatives, it's best to rewrite it as this. So this is shorthand cosine squared, meaning you're squaring the whole cosine function, the cosine and its angle. So now it's a chain rule here. So it's clearly a chain rule. So the outer function then is really 5x squared, and the inside is cosine of pi minus x, which also has an inside function, pi minus x. So I'll have to do kind of chain rule twice. So derivative of the outer is power rule. So the 2 comes down, multiplies by the 5, recopy the base. So we're going to do all that. 5 comes down, the 2 comes down, multiplies by the 5, recopy the inside, reduce the power by 1, now times the derivative of the inside. So that's this function here, right, the inside. The derivative of cosine is negative sine, and it has an inside. So I recopy its inside. Then do chain rule on that, times the derivative of the inside. The derivative of pi is 0. The derivative of negative x is negative 1. This is all stuff multiplied together. And you can think of this as a negative 1 times. So I'm going to go negative 1 times negative 1 times 10. I'm going to do all of that and put it in the front and call it 10. And then I've got times cosine of pi minus x times sine of pi minus x. Now I want to find the derivative I want to evaluate it at pi over 2. Which is going to be 10 times cosine of pi minus half pi. That's what pi over 2 is, right? Times sine of pi minus a half pi. So I get 10 times the cosine of pi over 2, sine pi over 2. So one of these is 0, right? Cosine of pi over 2 is 0. So 10 times 0 times whatever is 0.